In this section, we're going to do hypothesis testing for mu, which is the population mean, when sigma is known. Remember, sigma is the population standard deviation. So first, we're going to figure out how to find and interpret a p-value. So the first thing that we're going to do is figure out how to find the p-value. So to find the p-value, it's going to be different if we have a left-tailed test or a right-tailed test or a two-tailed test. Remember that a left-tailed test is shaded to the left, a right-tailed test is shaded to the right, and a two-tailed test is shaded on both ends. And when we're testing for mu when sigma is known, we're going to be using z-scores. So when we look up these values, we're going to use the standard normal distribution. So as you remember, it gives you the values that are shaded to the left. So P is going to be the area that you look up on this one. In this one, the P is going to be 1 minus the area that you look up. And in these two, P is going to be 2 times the area that you look up, because we have two tails. So we're going to look up a z-score, and then we're going to double that area. So we're going to practice doing this, finding the p-value, using this exercise 9 through 14, which is on page 373. And we're just going to do 9, 11, and 13. So number 9. On number 9, we have a left-tailed test, and it tells us our z-score is negative 1.32. So we're going to label that on there, negative 1.32, and it's shaded to the left. And then we want to get our standard normal distribution, table 4, and we look up negative 1.32, negative 1.32 gives us an area of 0.0934. So this is 0.0934. And with a left-tailed test, that's our p-value. So p equals 0.0934. It tells us that alpha is 0.10. So once we look up our p-value, so we've now found our p-value, then the next thing we're going to do is make a decision. So step 1, find the p-value. Step 2, decide. And the way that we decide is that if p is less than or equal to alpha, we reject h sub 0. And if p is greater than alpha, do not reject h sub 0. So in our example here, number 9, the p-value is 0.0934. The alpha is 0.10. Since the p-value is less than alpha, well, less than or equal to, because that's what it says, less than or equal to alpha, we reject h sub 0. So then how would we not reject h sub 0? Well, what if instead our alpha value was like 0.05? Then P would be greater than 0.05 and we would not reject. So that's how those ones happen. Let's look at number 11. Number 11 is a right-tailed test. So we've got our drawing here with a z-score of 2.46 shaded to the right. So when I look up 2.46 in my table, 2.46 is 0.9931. So remember that this area is going to be 1 minus 0.9931 because I have to do 1 minus the area I look up. And so that's my p-value. So p is going to be 0.0069. So I'm going to compare that to alpha, 0.0069 compared to 0.01. 0.0069 is smaller, so we would reject H sub 0. Because what that means is that the probability of my test score falling in that zone is smaller than the level of significance that I'm willing to accept. So we're going to assume that H sub 0 is not true. Well, we're not assuming. We assume that it's true, but we've just shown that it can't be true, so we're rejecting it. 13, we have a two-tailed test. And it tells me z is negative 1.68. So this is negative 1.68, and over here is positive 1.68. When I look up that area for negative 1.68, negative 1.68 is 0.0465, 0.0465, which means that this area is also 0.0465. So P is twice 0.0465, which is 0.0930. It tells me alpha is 0.05, so I compare my P, 0.0930, to my alpha, 0.05. This time my p-value is greater than my alpha, so I do not reject H sub 0. Let's write down the steps for an entire hypothesis test. So this is going to be the p-value method for hypothesis testing for mu when sigma is known. So to start off, verify that sigma is known, that the sample you're working with is random, and either n is greater than or equal to 30 or the population is normally distributed. Two, state H sub 0 and H sub A. Identify which one is the claim. 3, specify the level of significance. We always have to start our hypothesis test knowing our level of significance. It's unethical to run a hypothesis test and then go back and change your level of significance based on the results. So that's kind of one of the beginning steps. Step 4, find the standardized test statistic. The standardized test statistic for the mean, population mean, when we know sigma is a z-score, and it is x bar minus mu divided by sigma over square root of n. Hopefully you recognize that from chapter 6, because we used it there for confidence intervals. Step 5. Sketch and shade the curve and find the area that corresponds to z, that z-score. So that's going to use table 4. 6. Find the p-value. Now the p-value is going to depend on which type of test you have. So if you have a left-tailed test, then p equals the area in the left tail. It's the area that you looked up for your z-score. If you have a right-tailed test, your p-value is going to be 1 minus the area you looked up, because it's the area in the right tail. If you have a two-tailed test, p is going to equal 2 times the area in one tail. So you'll probably look up your negative z-score, and then just do 2 times whatever that number is. Step 7, make your decision, and that's based on comparing your p-value to your alpha. So if p is less than or equal to alpha, the level of significance, then you reject h sub 0. If p is greater than alpha, do not reject h sub 0. And then step 8, interpret the decision in the context of the original claim. And remember to use that, use the box. You know, remember that box from section 1 where we did the interpret the claim, if you reject or do not reject and all that stuff. Make sure you use that for your statements. Okay, the next thing I want to do is do an example all the way through. So we're going to do number 33, that's on page 375. So I'll put the instructions here so we know all the things we have to do. And then here's our problem. So we are going to start by identifying the claim, state h sub 0 and h sub a, find the standardized test statistic z, find the p-value, decide whether to reject or fail to reject, and interpret the decision. So essentially we're going to do like all 8 of those steps that we just talked about. They just don't list out the first couple. Okay, the first step was to verify that you know sigma and the sample is random, and n is greater than or equal to 30, or the population is normal. So here we have a consumer group claims that the mean annual consumption of cheddar cheese by a person in the United States is at most 10.3 pounds. A random sample of 100 people in the United States has a mean annual cheddar cheese consumption of 9.9 pounds. Assume the population standard deviation is 2.1 pounds. At alpha equals 0.05, can you reject the claim? So sigma is known, it's right there. The sample is random, says right there. And our population, or our sample size is bigger than 30, so step 1 is done. Step 2 was to state h sub 0 and h sub a and identify which one is the claim. So this consumer group claims that mean consumption is at most 10.3 pounds. So that's saying that it's 10.3 or less, so that would be H sub 0, mean is less than or equal to 10.3, and that's the claim being made, which means H sub A, the alternative hypothesis, is that the mean is greater than 10.3. The level of significance is given to us. Alpha is 0.05. Step 4 was the standardized test statistic. So we're going to find the z-score, which is going to be x bar minus mu. X bar was the random sample was 9.9, so 9.9 minus mu, which is the claimed mean of 10.3, divided by sigma over square root of n. Sigma was 2.1 over square root of n, which was 100. So we've got to get that z-score, and remember that z-scores we only need to 2 decimal places because that's all we've got on our table. So we'll take, I'm going to do 2.1 divided by square root of 100, which is 10. So I'll take 9.9 minus 10.3, divide that by that number, and I get a z-score of negative 1.90. Step 5 is to sketch and shade the curve. So I'm going to sketch my curve. My z-score is negative 1.90, and remember that the alternative hypothesis tells me which direction I'm shading, so I'm going to be shading to the right. So I put my z-score negative 1.90, and I shade to the right. So that tells me it is a right-tailed test. So I'm going to look up negative 1.90 in my standard normal distribution. Negative 1.90 is 0.0287. So then the area for this section is 1 minus 0.0287. Which is 0.9713. And that's going to be my p-value. Then I need to make my decision. Is my p-value 0.9713 compared to my alpha, which was 0.05? 0.9713 is bigger than alpha, and my decision is if p is greater than alpha, I do not reject H sub 0. So my decision is to not reject H sub 0. So I'm going to go back to my table about decision making. And I decided not to reject, so I'm in this row here. H sub 0 was my claim. So I'm in this box right here, and I'm going to say there's not enough evidence to reject the claim. But I also want to throw in there my level of significance. So I'm going to say at the 5% level of significance, there is not enough evidence to reject the consumer group's claim that mean annual cheddar cheese consumption by a person in the U.S. is at most 10.3 pounds.